Unlike many other post-combustion processes, the flue gas in a steel blast furnace contains significant concentrations of carbon monoxide and hydrogen, as well as carbon dioxide and air. Carbon monoxide and hydrogen are valuable gases as they contain energy which can be used in other processes to generate heat or be converted into chemicals. Extracting and utilizing the energy within carbon monoxide and hydrogen from the blast furnace gas is a primary challenge within the steel industry. Solvent-based carbon capture can help achieve this by removing the carbon dioxide from the blast furnace gas, and in the process, increase the concentration of carbon monoxide and hydrogen within the gas stream, which in turn increases its value. The iron and steel sector is energy and hence carbon intensive, with coal accounting for 75% of its energy inputs today. Carbon dioxide emissions arise directly from both the combustion of fuel to generate heat and energy required, as well as from the use of feedstocks and materials consumed in the process. This amounts to around 2.6 gigatons of direct CO2 emissions annually for the iron and steel sector. Applying solvent-based carbon capture technology to iron and steel making processes can reduce the direct CO2 emissions significantly. In fact, for the world to achieve net zero emissions by 2050, as per the 2016 Paris Agreement, industrial CO2 emissions will need to fall by around 45% by 2030 alone. Solvent-based carbon capture technology has the ability to achieve CO2 capture efficiencies above 90% and high selectivity of CO2 over other components in the gas stream. This results in the production of higher value off-gas streams that can be utilized for their energy content. If the off-gas is recycled back into the blast furnace as a fuel gas, it can increase the energy efficiency of the steel production process, whilst also lowering the direct CO2 emissions. APBS-CDRMax is a low-cost, high-performance carbon capture solvent, which compared to industry standard solvent technologies available, requires lower energy inputs and smaller equipment sizing. It has a longer solvent lifetime, lower emissions to atmosphere, and less solvent makeup requirements. This makes APBS-CDRMax a greener and more economically viable solution than competing solvent technologies within the iron and steel sector. Carbon Clean has recently commissioned a plant at a steel facility to capture 5 tons of CO2 per day from steel blast furnace gas. The captured CO2 will be utilized on site to create a local circular carbon economy.